Hi, in this screencast I'll be showing you how to create a simple chat application using Netty in under 15 minutes. First we'll need to create a new Java project and I'm going to use Maven for this. For this screencast I'll be using the Netty all library. And to avoid some runtime warnings I'm also adding the Java assist library. Also, since we're not living in the dark ages anymore, I want Maven to use the latest Java 1.7 for this project. Alright, now we're ready to get started. Let's create a new class called the chat client and we'll need to assign it a new package. Let's create a constructor using two parameters, the host to connect to and the port to connect to. And let's store these into two local final variables. We'll also write a public run method for the actual client behavior. First we'll need an instance of Netty's new IO event loop group. Next we're going to use the bootstrap class to set up a channel using this event loop group. And we're going to tell it to use the new IO sockets. Finally, we'll tell it that we want the channel to be handled by a chat client initializer class, which we'll implement in a minute. Now we can ask the bootstrap object to create a connection to the server using the specified host and port. Once connected, we can ask for the channel object, which we can use for interaction with the server. We'll also need a buffered reader to capture the user's input from the console. We'll add a while loop which takes the user's input from the console and writes it to the server. And finally, when we exit the loop for whatever reason, we'll need to shut down the event loop group. Also, let's add a main method which we can run to start a chat client on port 8000 on localhost. Now it's time to implement the chat client initializer. Instead of implementing the general channel handler interface, we wanted to extend the channel initializer class. Keep in mind that we want this class to initialize socket channels, so we'll need to make some changes. Here we'll define what Netty calls a pipeline. It basically describes how we want to organize our communication. First we'll tell Netty we're expecting frames of at most 8192 in size, each delimited with line endings. Since we're just exchanging strings between the server and clients, we can use the string decoder to decode received bytes into strings. And we can use a string encoder to encode strings into bytes, which we can then send over to the server. And finally, we'll need to define a class which will handle all the decoded incoming strings from the server. This class will need to implement the channel inbound message handler adapter class. Note that we want this class to handle incoming string objects, so we'll have to modify it a bit. All we want to do is to print any string message we receive from the server to the console. All that remains for the chat client are a few calls which could potentially throw exceptions. For simplicity, I'm just going to ignore these. The chat client is now finished. Now let's start on the chat server by creating the chat server class. We're going to create a similar setup as to the chat client class. Let's start by creating a constructor with a single parameter, the port to listen on for incoming connections. And let's store this in a local final variable. Next we'll create a run method which will listen for incoming connections and hand them off for processing. We'll also need two new I/O event loop groups. The boss group will accept incoming connections as they arrive and pass them on for processing to the worker group. Similarly to how the chat client class uses the bootstrap class to set up a channel, we can use the server bootstrap class here to define how the server will process incoming connections. We first specify that it should use the boss group and the worker group. And like the chat client, we want to use the new I/O server sockets for communication. Next we need to specify a class which will handle any incoming messages. We'll implement this in a minute. Finally, we can tell the server bootstrap object to bind to the specified port and start listening for incoming connections. And before we exit the run method, it's a good practice to clean up the used event loop groups. Let's also add a main method which will start a chat server using port 8000 to listen for incoming connections. Now it's time to implement the chat server initializer class. Again, we don't want to implement the general channel handler interface, but rather extend the channel initializer class. This initializer should initialize socket channels, so we need to make some minor changes. Like the chat client initializer class, we'll need to specify the channel pipeline. However, the framer, decoder and encoder are the exact same as in the chat client initializer class, so we can just copy these over. Finally, we'll need to specify a handler class which will handle any incoming messages from the clients. This class should extend the channel inbound message handler adapter class in favor of implementing the general handler interface. We'll need to slightly modify it because we're going to process incoming string messages here. In order to identify who has sent us a message, we can ask for the channel object. Next, we'll need to send a message to everybody else. We can do this by iterating over all known channels and write a message to each channel except for the one on which we received the message. We can keep track of these channels in a channel group object. Remember that we should only send the message to all channels except for the one which has sent the message to the server. We're almost done. We still need to keep track of our active channels. We can do this by overriding the handler added method. This method will be called when a new chat client connects to the chat server. Here we can notify other chat clients that a new client has joined. And finally also add it to the channel group object. We'll also need to keep track of when chat clients disconnect from the chat server. We can do this by overriding the handler removed method. Here we can also notify all chat clients that one client has disconnected and left the conversation. And finally, remove it from the channel group object. Finally, one method call could potentially throw an exception, but I'm going to ignore this in this screencast. Alright, we're done writing code. It's time to test our new chat system. Let's start by running a chat server instance. Next, I'll start a chat client. Also, let's add and position a second console view so that we can display two chat clients side by side. As you can see, there is only one chat client running, so let's start a second one. On the left you'll see the first client, and on the right the second. Now let's play around a bit. Alright, everything seems to be working properly. Thank you for watching this screencast. I hope you've enjoyed it.